We have a series of slots here on the front face of this model. When looking from the front, the pattern is constrained within a rectangular boundary. Along the edges of the boundary, some of the slots are cut short, but they are still able to achieve a full round fillet. When I attempted to devise a viable workflow for this pattern, I set myself the following two criteria. There should not be a need to manually suppress pattern features. There should also not be manual filleting of each individual slot one at a time. I have a sketch rectangle here that delineates the pattern region. I'm going to use this sketch to split the body. Go to Modify, Split Body. Select the body to split. For Splitting tool, click on the Select box and select the sketch. I have prepared two slot sketches here, which will serve as a seat. In order to achieve the staggered pattern, one slot would have to be slightly higher than the other. I will use this sketch to perform an extruded cut. Ideally, we do want to control the extent of the cut up to this face, in order to keep this parametric. But after some testing, I have found that this really slows down the pattern feature thereafter. So let's do a distance instead. Adjust the distance to exceed the face in question, so that it cuts completely. If we expand objects to cut, we can see that it cuts only the body that has been split out. Keep this in mind as we move on to the pattern feature. Go to Create, Pattern, Rectangular Pattern. For Type, select Features. And select the extruded cut. For direction, select the x-axis. Once the x-axis is selected, it automatically offers up the y-axis as a direction also. Set distance type to spacing. Set both direction types to symmetric. Adjust the quantity and distance. We should adjust this such that the pattern exceeds the rectangular boundary. We do not need to worry about the pattern cutting into the main body. This is because the pattern feature honors a cut condition in the seat extrude and will limit the cut to the rectangular split out portion. Set Compute option to identical, as we want the patterned cuts to follow the seat cut exactly. This also helps to speed up the patterning process. Go to Modify, Combine. And combine all these bodies into one. At this moment, we can see that some of the slots have been cut short due to the rectangular boundary. It is possible to perform a full round fillet for each of these individually, but that will be tedious. A better way is to employ the rule fillet. Begin the fillet command. Set type to rule fillet. Set rule as all edges. In this case, the edges of interest were created when we performed the combine command. So we should select the combine command from the timeline. For topology, we have the option of selecting either rounds or fillets, or both. Rounds remove material from external corners, while fillets add material to internal corners. In our case, since we are dealing with internal corners, we should select fillets. In order to achieve the full round fillet, we need to adjust the radius so that it matches the radius of the slot. The command would automatically seek out all internal corners produced by the combine command and add material to round them off. Depending on how the rectangular boundary interacts with the pattern, the slots might be cut off too short. This might create problems during the filleting process, so you do need to adjust the boundary or even the slot pattern as required. Another interesting thing to take note is that if the C-cut somehow straddles across a rectangular boundary, this will not be a problem, so long as you make sure that the correct body is cut.